So this video is an introduction to systems mapping and a bit of a look at participatory systems mapping, where a group of people come together to map a system. So normally a mixture of domain experts and then sort of mapping experts as well. So it's useful to kind of quickly refresh your memory about a few terms, or introduce you to a few terms if you've not heard them before, just so this makes a little bit more sense. So system is often used to refer to the thing you're interested in understanding. And there are various definitions out there, but they're all relatively similar. So here's one. A system is a group of interacting or interrelated entities that form a unified whole. Or from the Oxford Dictionary, the one at the bottom, a set of things working together as part of a mechanism or an internet connecting network, a complex whole. So the idea, or rather the commonality between these two definitions is that it's a kind of a collection of interrelated entities that together form some kind of whole, and that whole is the thing that you're interested in. So it could be a service provision, an organisation, or some other kind of, anything really, from biological systems right up to societal systems. And you'll notice that there's sort of one definition has a sort of the notion of a network in there as well, and people do sometimes swap between saying network and system, particularly when they're talking about systems maps, which are often visualized as some kind of network, and we'll sort of see a few of that kind of thing as we go along. A couple of other ones worth keeping in mind. So people often talk about nodes and edges. So nodes, they're the sort of blobs, sometimes called vertices as well, and they usually represent some sort of entity in the system that you're interested in. So it could be an organization or a person. It could also be things like documents and policies as well, or places. So it doesn't have to be necessarily a physical object, but some kind of object in a way. And then edges, they're the lines or the arrows that go between the nodes, and they capture a relationship between two particular nodes, so a relationship between those blobs. Common sort of relationships could be things like employed by, friends with, director of, etc. And then network and graph, like I said, can often be interchanged as well. So network, system, but also some people talk about graphs when they actually are referring to networks as well. So what do they look like? So hopefully this kind of thing is quite familiar to you. So here's a sort of Mickey Mouse system map I did. So I have a kind of service domain that we might be interested in, and then I sort of mapped the relationship between different parts of that system that influence how it works. So there's the system as a whole, and then these are the parts that are within it that interact. So things like local policy defines a public service, an economic group is dependent on that public service, and so on. The boundaries of systems are often denoted as kind of permeable, and that's to kind of get this idea that they're often not closed. Things can come across these boundaries, so you have inputs from the external environment into your system that you have to be aware of. And actually the boundaries themselves can be kind of pragmatically drawn, so it might not really exist, but you have to put a boundary somewhere in order to be able to do the mapping and sort of understand what your capacity to influence that system is, even if really it extends beyond your boundary. So it's worth at this point just kind of reminding you that it's not necessary to map a system in its entire detail. So you can sort of do a sufficient amount of mapping for the purpose of what you're trying to do. And there's a nice quote here from Stafford Beer, who was an early cybernetics systems mapper in the sort of 50s and 60s mainly. So he said, instead of trying to specify a system in full detail, specify it only somewhat. You can then ride the dynamics of the system in the direction you want to go. So what he's saying here is it's not necessary to spend ages and ages mapping a system in complete detail. You can do it to a level that you think is appropriate. It can also, that can evolve over time. And then you can ride the dynamics of the system direction you want to go. And essentially what he means there is once you have an understanding of the system in terms of a map, you can then sort of look at what you might need to change to change how that system behaves. So the rest of the talk I'll split into 4 bits, and you can kind of skip between them as you like. So we'll introduce a few things about nodes and edges. There's a few things sort of methodologically that it's worth kind of thinking about in terms of nodes and edges and mapping as a whole. And then after that, we'll sort of talk a little bit about how to get started with mapping, what systems maps can be used for, and then the kind of more analytical side of systems analysis, which it'll only be really an introduction here because that's probably at least a few talks in its own right. So a couple of things about nodes and edges that are worth sort of being aware of. So as a kind of refresher, they're often drawn like this, maybe not a circle, but could be different shapes. And actually, different node types would probably have different shapes in a system map if you were doing it a little bit more systematically. So nodes, they can have attributes. So if this was a person, they might have attributes of age and height, things like that. And like I said earlier, a node you would say is, if you can sort of prod it, it's probably a node, so an object or an entity in that system. But policies could be a node, a little bit less tangible. But also you might actually want to map an issue as a node. So for example, if you're interested in child poverty within a particular part of your system or the area that you are interested in understanding better, it might be worth mapping as a node, because you could have things, the child poverty as a node could have relationships with other parts of your systems, either things that alleviate it or exasperate it or whatever. So it's not always sort of physical entities, basically. And then the edges. Edges can also have attributes. Common attribute on an edge might be a date, so the time at which that relationship started or ended. Another attribute that's common actually is edge weights. So the strength of the relationship can be indicated by the weight of it, and that's often depicted by a thicker line, or a larger line, or different color line, something like that. And that's useful for analytical purposes, but also just sort of visual. You can see that some relationships are thought to be stronger than others. And then also directional. So it might be that there's a directionality to the relationship. So a person works for an organization, or a person wrote a document, that kind of thing. And we'll have a look a little bit more at these in general, and actually the relationship directions can be quite useful to capture. So we'll look at that here. So here, this is really a kind of a look at directionality. So we've got 2 people, and then person A can be friends with person B, but person B might dislike person A. So you can see that actually the direction of these arrows and the fact that you have more than one arrow captures some of the dynamics of this relationship that just one straight arrow with no ends wouldn't. If they were both friends, you can either have an arrow that was a line that was 2 arrows, or you could just have a line saying friends, and that would indicate that they were both friends with each other. So it's just worth keeping in mind that directionality can capture some of the dynamics at some points. And then go back to weights. So here, person A and person B again. Person A loves person B, so that's a stronger, more weighted connection, but person B only likes person A, so that's a weaker relationship. So again, this captures some of the dynamics of the relationship between these 2 people in a sort of an easy to understand way. So another thing on nodes, edges and attributes that's worth thinking about. So here's a person, so they might be a node in our network, and they'll have attributes again, age, height, weight, color, etc., etc. But address, now often this kind of mistake is made. Address is not an attribute of a person. So some people might put the address of someone along with these attributes, and that doesn't really make sense. Your house doesn't stick off you in this way. because it's actually in a relationship. So here's the address and there's the person. So that's that person's address. So you could also have the relationship lives at or lives in. And it's just worth bearing this in mind, because this is quite an easy example of highlighting this issue, but it does come up quite a lot that sometimes it's a little bit tricky to actually figure out what's best to capture as a relationship between two things in a network and what's actually an attribute of one thing. So it's just worth bearing in mind. So once you sort of assemble all of these parts, you can start thinking about building a system map of something. So this is back to my sort of pretend local government service or whatever it is. So here I've decided that within my service domain, I've got something that represents local government, which implements a policy. It's also wrote that policy, which defines a public service and also defines how it's funded, perhaps. Although the funding could have perhaps come directly from local government, so you could see how that might actually, having this map might trigger you thinking about how to adjust it to make it more accurate to what actually happens. But this local service, there's a certain group of people that are dependent on it, but it's actually managed by a voluntary organisation, and that organisation regulates itself. So you can see just with a few lines and a couple of blobs, I've actually captured quite a complex system here, and you could potentially then look at either how it ought to be changed, or even if indeed this is how it actually works. But the other thing to keep in mind that's often, well, not often, but can be overlooked, is that actually just doing this, just going through this process in of itself, is quite beneficial. You can learn quite a lot about how things actually work on the ground just by trying to map them. So it's almost an end in itself. You may not need to go much beyond this point to actually get a lot of benefit from systems mapping. But of course you can extend this. So here, this is a useful way of thinking about boundaries of systems. So my service domain has a boundary that I've decided, because it is kind of slightly subjective decision that it sort of goes around these parts. But there's a central government part to my system that I can't really influence very much, perhaps. So I've separated it off. So I've got a central government here, and there are inputs from this system into my system that perhaps I need to be aware of. So central government funds local government, or at least in this case to a degree. Central government regulates this public service that I have to locally implement. And there's a national policy that restricts what you can do at the local level. So you can see that this is a different system because it's a national government system, and I might have quite limited ways of changing this, but I need to be aware of the inputs from here into my system. So you can see that it creates more complexity that you have to be aware of. Similarly, you might actually have another service domain over here, which has its own components, its own interaction with central governments, but perhaps importantly to you, it also interacts with the service domain you're interested in. So my public service is an input into this system, and then there's a part of this system that affects this economic group, which are dependent on my public service. So again, just by going through this process of mapping, so now you've mapped one system, but now you've mapped another, and you're also aware of central governments as an input to both of these systems, you can start to understand both how they internally work, but also how they interact with each other. And the complexity of the story will increase as you get more and more systems. So just as another example, so this is worth checking out as well, basically, as a group that I'm an advisor to this group, not directly involved, but their work's quite good. And they do something quite similar, but they're quite interested in causality. So they focus, when they're doing their mapping, on causal impacts. So they've got an energy system here. I don't know exactly how this energy system works, but even just looking at this map, you can see there are various relationships between things like the feedstock to the energy system, the infrastructure, funding, policy, and all that kind of thing. And then they map the relationships with 3 different strengths, so 3 different weights from weak to strong. One area that I'll just mention a little bit is this community acceptance that they've mapped to a node. This is where I would perhaps depart a little bit with the way that the CCAN group do things, because I wouldn't necessarily map that in this way. And the reason is that if we look back at our sort of discussion of nodes, edges, and attributes, can an attitude like resistance to change or community acceptance really be a node? So we've seen that CCAN do this. And it might be better actually to represent a group of people and then their relationship to something being the attitude. So how I would choose to do this is have a group of people, group A, that resistance to change of a local service provision, which I think works a little bit better than having a node where, because this doesn't really give you much option to sort of unpick what this actually is. So is it a particular group of people? What's their acceptance of, etc., etc. It's just worth bearing in mind. It's not necessarily this is wrong or anything. It's just perhaps not how I would prefer to do it myself. Okay, so starting with mapping itself as a process can feel a little bit difficult to get going sometimes, but I think the key is to start pretty rough and at a relatively high level. So remember what Stafford Beer said basically, which is don't worry about being complete, particularly at the start. It's a process that can evolve over time. And use a medium that's easy to kind of move things around. So you can kind of have something that represents those blobs, like sticky notes or whatever. You can move them about, put them into groups, perhaps even start mapping the relationships between them, and then build the detail as you go. And one way to think about this is it's an exercise in surfacing mental models that people already have. So when you think about the thing that you're responsible for, the system that you're responsible for, you probably do think about it as a kind of set of interacting components. So, different parts of that and how they relate to each other. So it's about surfacing that model for yourself, but also for everyone else, and then looking to see actually, well, if you agree, but also if you're actually talking about the same thing, basically. Start with the thing you're interested in as well. So go for the kind of the issues that are kind of present in your mind and how they interact with people and organizations in the system. So start with the kind of I suppose most pressing issue that you're interested in, I suppose, is a way of phrasing it. But the thing that you want to understand the most. And then think about organizations and capturing them as nodes, as relationships to others. So map what is there first. So, the situation as you face it, start on that. Then it might be worth mapping things like where external things like policy interact a little bit later. So then you can think a little bit wider about what the inputs to your system are after you've mapped it. It might be useful to develop some rules, maybe not straight away, but certainly relatively quickly, about node types and relationship types, just to give you a bit of structure. That's not too important, particularly initially, but if you limit the types of nodes, like organization, person, policy, documents, it can actually force you to think about what they are a bit more. And also remember, do your relationships have direction? Does that actually matter? Once you kind of get going a bit, it's good to get a diversity of views from the domain experts. So who are the people that you might need to actually talk to? So stakeholders, members of an organization, etc. And code produce it when possible. So you can map things on your own. That's fine. But it's better to get a plurality of views, diversity in those views, to make sure you're not just mapping one person's view or one person's experience. Not necessarily wrong, like that person's experience is legitimate, but it might not be universal. It can be advantageous to map people into a system. So often that's actually not done because obviously it increases the amount of blobs and relationships that you have. But people tend to glue organisations together, and information tends to flow through people. And then things like a high turnover of people can affect things like organisational memory and sort of tacit knowledge. And also when you get onto the kind of more advanced analytics, so if you're thinking about embedding this as organisational practice, having the people there can actually give you some notion of sort of where the knowledge or even where the power sits within an organisation. So it can be useful to map people. How do you stop? So this is a bit of a tricky question because, like we already said, systems tend to be open. So they have a boundary, but it's very kind of fuzzy. It's a permeable boundary, and it might be drawn purely kind of pragmatic or even political reasons. It might be the edge of your jurisdiction, for example. So if you can't influence it directly, it might just be worth putting it as an input into your system. So you can map in detail the things that you actually have some capacity to change, perhaps. But then if something's outside of your capacity to change, you could just put it as an input and then not worry about mapping it in any more detail at this point. Obviously, that's a decision that you may need to review or think about. It might be that some things that you can't change actually need to be brought inside. But it's a way of looking for the limits of the system, so you don't end up mapping the whole universe, basically. Another way to stop actually is to look at the kind of the dynamics of the network that you've produced. So do you have any sort of dangling ends that aren't connected to anything anymore? So here, this part of the network is quite dense. There's quite a lot going on here. Lots of interactions, lots of connections. But here, and this could either be a reflection on the fact that we don't know enough about this part of the system, so you actually might want to go and map it more, or it could be that these people on this edge, so these are people out here, don't really influence this system very much, and you could basically exclude them from further mapping and sort of concentrate on this much more complex story down here. This kind of problem, so this sort of where to stop problem, does depend a little bit on how you're doing your mapping. So if you're mapping based off documents, it's easy to carry on forever. But if you're mapping mental models, so out of people's personal mental models, then you'll reach a natural stopping point a bit quicker normally. So that's worth just moving on then to actually where does the data come from. So some maps are built from document analysis. So you can actually go through and look for relationships between parts of a system by analysing the documents and policies and websites that the entities within that system produce. And there's two examples here of some document-based systems that I've built. But also, not only could you mine documents, but you could also look for the input from people in workshops. So you could have some mapping done from documents, like policies, who wrote them, etc., etc. But you could also have additional input from actually talking to people in workshops that you can then input into these maps. Then the most common, perhaps, and certainly where a lot of these things start, is looking at workshops with people. So you can take things like what people have drawn on boards, or what they've done with sticky notes, or drawn on paper, or whatever it is, and then start to build kind of formalized system maps afterwards. So you don't actually necessarily have to get much beyond this stage, really. This might be enough to do a lot of kind of collaborative mappings together, and then you maybe want to capture it formally at some point, but this process is often very beneficial on its own. Okay, so what can you use them for once you've got one? Well, like I said, it does not necessarily, you don't have to get to this point. Just getting to the point of having a good map and doing the mapping process is often very useful, but they actually are they can be analysed in their own right. So try and develop a map that most people agree is a reflection on the actual system. So you sort of settle on a representation of that system. but a caveat to that is retain where there are disagreements, because that's likely to be important. So where there is disagreements, that might reflect areas of contestation or confusion, perhaps around responsibility or jurisdiction, etc., or just an understanding of the system itself. Look for where assumptions about a system can be challenged. Try to capture what's on the ground and avoid overcomplicating. So when you're actually using it, it's useful not to overcomplicate it. So that might influence your decision about whether to map people, say. It might not be necessary at first, for sure. Try to understand what needs to happen across the map to improve areas of concern. So that's this notion of kind of riding the dynamics in the direction you want to go. So you've probably got a sense of what you think needs to change to make something better. Now you have a map of all the connections and relationships between that and the other parts of your system. So look about how you can follow links, perhaps change relationships to improve the thing that you think is an issue. Look at the inputs, look at the outputs, etc. You also have an understanding of what perhaps could be coming in from other systems, hopefully, and going out to other systems from yours. So you might be able to have a better understanding of like ripple effects due to changes elsewhere. It's also worth noting that ultimately, and this is why it can be useful to have a kind of formal structure and a little bit of rigor about what you're doing, because you could translate them into agent-based models. So you could turn your map into a model and then look at changes and see how that happen, simulate the effect of the changes you might want to do and see what they do on to the system as a whole. I'll just very quickly look at a bit of analysis just to kind of highlight what's possible as well. We won't look at modelling, however. So when you analyse a system, you can look for things. You can look for features in that network or that system map that relate to sort of known possible behaviours that we can see in systems in general. One of them is types of feedback. So negative feedback is where an input to a system produces an output, but that output actually reduces the activity of the system and makes less output. So something comes in, the system produces an output, but the output naturally damps down the system itself. These are quite stable. So even though you've got something that's kind of coming in and making something happen, it doesn't run away with itself because the output restricts the production of itself, basically. So they're quite stable in systems, and quite if you've got something like this, you can probably be relatively sure that there's not going to be massive instabilities in what your system is doing. Positive feedback, however, is something to perhaps worry about. So an input to a system creates an output. Then the output actually feeds back into the system and creates more output. So this system's going to run away with itself. So there are certain types of things in your system that you really don't want to be in a positive feedback loop, because that's going to amplify it and could be very detrimental to what you're trying to do. So you can analyze your system, your network, to try and see if these feedback loops actually exist. You can also use the structure to actually demonstrate something. So I've got two examples here that do that. So they've actually refactored their system. So the relationships are actually now more indicated by the positioning in these diagrams. So it's just something worth thinking about, is actually that you can kind of you can use these as an information tool to say something about the system that you're interested in. So this is the NHS. It's also, this is going to be something that you might be thinking of embedding as sort of organizational practice, you can actually store data in a network and then use it later. So here, pink dots are universities, grey dots are universities, pink dots are people, blue government organisations, and this is stored in a structured way using a tool to support it. It's a network database. That might be kind of more than you need in most cases, but if you do this, you've then got much more options for analysing this or even turning it into a simulation than you would if you just stored it as even a kind of line diagram or whatever, or photographs of whiteboards, etc. So the other thing that you might, if you have that kind of more formalized structure, you could do analysis like look for things like degree centrality. So that's just the measure of the number of inputs. Well, that would be in degree. So in degree would be the number of inputs to a node. Out degree would be the number of outputs from a node. And then just degree centrality would be just the total number of links that a node has. So I think this is one's got 6. So it's got 1, 2, 3, 4, 5, 6 in by the looks of it. This one's got 7, 1, 2, 3, 4, 5, 6, 7 in, yeah. And obviously you can only do this kind of analysis if you have some kind of formal structure that your network's stored in to allow you to analyze it with some kind of network analysis tool. And this might just tell you something about how important this node is in your network. There's another one called betweenness centrality. Then that tells you how many paths, so how many routes through the network are dependent on certain nodes. So to join this node with other bits of the network, for example, or these 3 nodes rather, that means that there's 36 different possible paths that go through here, and then this one, it's 70. So to keep this network connected together, 70 of the possible routes through this network go through this node. So that's undirected paths as well, because there's no direction on these edges. And that can tell you something about the importance of individual nodes. So these might be people, and you could sort of say that this person is, connects all those different people, 70 different pathways through this network. So it might tell you something about the power of the network or the power dynamics in the network. And again, it can only be done if it's if the network's stored in a suitable way, basically. You can also do things like core periphery analysis, and that just basically assigns a coreness measure, so how sort of core you are to this network based on the connections you have between other nodes. So these 4 blue nodes in the middle are highly connected with each other, so they're very central. And then we've got a second layer of green nodes that are sort of in the middle, and then a peripheral set that are kind of loosely connected. Again, it can sort of give you an indication of where the sort of central part of the network is. And then you can also look at things like community detection. So obviously these networks are quite big, and that's how this analysis works. But you can use algorithms to assign nodes to different communities within your system, your network, and that might actually correspond to something in the real world as well. So that's where I'm going to leave it. So it's quite a quick tour of network, systems mapping and a little bit of network analysis at the end, and some of the kind of tips about how to do this kind of stuff. There are a number of different tools that can help you. So GraphViz is an easy networking tool. Neo4j is a network database that I use. It's a bit more advanced, but it's not too difficult. Gephi is not a bad visualization tool, but it's quite it's not been updated for some time. It's getting a bit old, so it can be a bit unreliable. iGraph and R are good for network analysis and visualization, but a little bit trickier to use. And then the Centre for Evaluation of Complexity Across the Nexus is another group of people doing some really interesting work in this area. And here's some references. Okay, thank you, and I hope that this introduction is useful.